Hello everyone. Today, as I mentioned in the email, will not have any live class. Instead, I'll record the lecture and send the recorded files to you. So today, first of all, I would like to start from where we left yesterday. So previously, I'll just go there and briefly discuss what happens when we talk about domain and range. If you remember uh, the example of mango and tree, we said if all the elements of the domain, that's our domain of course, and that's our codomain, if all the elements of domain are related with codomain, then we need to check whether we have more than one element in the domain which is related to the same element of codomain. Then we need to check whether we have a single element of domain which is related to more than one element in the codomain. Okay, so let me show example of these two. So let's say A, B, C, 1, 2, 3 are the elements. So let's say A is related to 2, B is related to 2, C is related to 3. Okay, so that's the first case. More than one element, as you can see here, is somehow related to the same element in the codomain. And we'll say that if that's the case, that is a function. Okay. Okay. Secondly, let us just remove these relations. Okay. Secondly, let's say A is related to 1, B is also related to 1, C is related to 2. So now we have more than one element. Oops, sorry. I've just used the same example. Let me remove this. Sorry. So B is related to 3. Okay. B is related to 3. And A is also related to 2. Okay, now this makes sense. Okay. So now we can see this element A is actually related to more than one element in the codomain, as you can see. A is related to both 1 and 2. Can you see that? So one element of domain is related to more than one element in the codomain. We say that, hold on, this is not a function. Okay. Let's go to number 3. Just a quick reminder, this is just a brief flashback to the lecture what we had yesterday. So if you had these things clear on the last lecture, you need not be worried. Okay. Okay. Next one. So let's again first remove this. Okay. Now we say that A is related to 1, B is related to 2, and C is not related to anything. That means we have a condition where one element in the domain is not at all connected to any of the elements in the codomain. As you can see, C is not really related to any element in the codomain. If that's the case, once again, we'll say this is not a function, okay? And the last one, remove this, okay. The last one is, if we have something like this, let's say A is related to 1, B is also related to 1, C is related to 2. So we have an element in the codomain which is not related to any element in the domain. As you can see, 3 has no relation with any element of the domain. If that's the case, we'll still say that this is a function, okay? We'll say this is a function, no problems with that, okay? So that's the brief, you might say, conditions for a function. So now, using this, we just want to check uh, with a with an example, worked out problem, okay? So let's just take this example first. First example, 2, 6, 5, 5, 7, 5, and 1, 15. Okay, so we need to check whether this relation given by this set, as you can see, we have used this, so that means this is a set, and of course previously we have seen this is ordered pair. The first element is from X, which is the domain, and the second element is from Y, or we'd say the range. Okay, so now we need to check whether this relation is actually a function or not. Okay, so what you can do, you can just set this here. You can actually eyeball it though. You don't need to graph it. I'll soon show how it can actually eyeball it and check whether it's a function or not, okay? So that's your X and Y's, okay? So 2, I'm just taking the first element because as you know, always from the ordered pair, always the first element comes from X, second element comes from Y. So if I take just the first elements, 2, 5, 7, 1, and the second elements, 6, 5, 5, 15. And the relation is 2 is related to 6, 5 is related to 5, 7 is also related to 5. We'll actually remove this because if we have a repetition, we can actually avoid that and write it once. Okay, if we have anything more than once, we can actually write it once and use that for showing the relationship like this, you know. For both 5 and 7, as you can see, we have a relation with 5. So you can actually avoid writing 5 twice and write it in this fashion, okay? So next up, we have 1 with 15. So as you can see, first of all the elements of the domain is somehow related to the codomain or range. We know that it's these are the range. So the first one is satisfied. Next up, we have more than one element in the domain related to the same element in the codomain or range on this occasion. So that's still okay. We don't have one element of domain related to more than one element in the range. So that's what we want. So overall, we can say that yes, this is a function. Okay. So now the question could be, do you actually need to spend this much time to see whether we have a function or not? And the answer is no. You can actually eyeball the ordered pairs and see and check whether it's a function or not. Let's try this one. Let's try our next worked out example and see how we can just eyeball and say that, yeah, this is a function, or no, this is not a function, okay? We can actually eyeball and decide. So 3, 3, that's not a decimal point though. That's 3, 3, 2, -2, and -5, -3. Okay. Now we want to eyeball and say whether or not it's a function. Okay. We don't want to spend too much time, and we don't want to graph this all the time, right? Okay, so what we need, if we have an ordered pair like this, all we need to check whether we have one single element in the domain connected to more than one element in the range. Okay, so we just need to check whether we have the same, let me write it for you. Need to check whether we have the same element in the domain related to, related to two or more elements in the codomain, or on this occasion, these are all ranges. So we'll say range. Okay. Now, so that means we need to eyeball. First of all, we need to eyeball if we have the exact same value in the domain. And if we eyeball it, let me first underline the domain, elements of domain. And if I just eyeball, I can see, yes, I do have -5 twice. That means more than once. And that guy is, first of all, related to 1, and then it's related to -3. That means one element in the domain is related to more than one element in the codomain or range. So we'll say, nope, this is not a function. Okay, that's the best way. You can eyeball it and check what happens, right? Okay, now what happens if we have a function instead? Okay, let's try our third example. What happens if we have a function like, say, y equals 3x plus 7? This is a function where y is the dependent variable and it depends on X. So we say X is independent, okay? We need to check whether this is a function or not, okay? This equation. Now, again, if you remember the basic property of domain and range, if you remember the condition for a relation to be a function, we know that for the same X or the same value from the domain, and here of course X is the domain, the values of X is for domain. So let me write that first. So values of X will be our domain, values of Y will be our range. So for the same X or for the same value from the domain, we just need to check whether we get two different values of Y, two or more in fact, two or more Y's. If we get two or more Y's for the same X, we'll say that's not a function. Otherwise, we'll say, yes, that's a function, okay? Let's just check that. So if we have, if we can somehow graph that, we can actually check that. But what's the best way to check whether, even without graphing it? So first of all, I'll show how we can check by graphing. Then I'll show how you can actually eyeball it, or maybe a little bit of calculation will tell you whether that's a function or not, okay? So first of all, if we want to graph this, we need at least 2 points, right? So if I plug in X equals 1, I get Y equals 10. If I plug in X equals -3, I get Y equals -2. Okay. So if we have 2 points, if you remember the basic property of graphing, we can always graph it. So this will give us an ordered pair of 1 and 10. This will give us an ordered pair of -3 and -2. We can actually graph it by using these 2 points. Okay, so 1 and 10. So that's my 1, 2, 3. -1, -2, -3. That's my 5. That's my 10. That's my -5. That's my -10. So 110 is 110. So that's my 110. And -3, 2. So that's -1, -2, -3 here. And -2 will be somewhere here. Okay, yeah. So that's our point. So if I just add these 2 lines, this will be the graph of the given equation. And from the graph, if we just draw a parallel line to this y-axis, this is our y-axis, right? The red one. If we draw a parallel line to this y-axis, anywhere on the graph, let's say here, and once here as well, anywhere in fact, if we draw a parallel line to the y-axis on the graph, if we don't get more than one values where the line intersect with that parallel line, we'll say that that is a function. So as you can see, as I've drawn a couple of parallel lines, the white line has intersected at only one point. Can you see that? The parallel line didn't go through more than one point with that line, right? It has only one intersection point for each parallel line, not more than one. So we'll say it's a function. So that's by graphing. So the rule is you need to draw parallel line to the y-axis, and if it intersects, if the graph intersects that parallel line in more than one point, then it's not a function. Otherwise, it's a function. Okay? So that's the basic. From graphing, of course. Okay. Now what happens if we want to just calculate it and we don't want to graph it, because of course graphing takes a lot of time. We don't want to spend that much time. We just want to see what happens if we just eyeball and do a little bit calculation, then whether or not we can decide it's a function. Okay, so now let's try this one. We have 6x plus 3y squared equals 2. Again, just a quick reminder, always remember x is the independent variable, so that's your domain, and y will be your range. That's dependent on x. So always we'll try to isolate y. If you remember math 95 or math 96, we did learn how to isolate a variable. So first of all, we'll isolate this y. So I'll keep 3y squared. I'll change sides for this. So it will be 2 minus 6x. Okay. Now, as I'm trying to isolate this y, I'll divide both sides by 3, right? Because I'm trying to isolate this y. So 6 over 3 will be 2. I've just divided these two by 3, okay? And again, I'm trying to isolate a single y, of course. So I need to get rid of this squared. And the only way I can get rid of this is if I take square root on both sides, okay? So 2/3 minus 2x. And of course, we'll have a plus minus. Whenever you are finding a square root, we'll have two different values, plus minus y, okay, plus minus values, okay. So now that's the first thing we need to do. If we have an equation like this, the first thing we need to do is to isolate a single y. Then we can actually eyeball it, that whether it's a function or not, okay. Now, if I plug in x equals 0, can you see what's going on here? If I plug in x equals 0, I'm getting y equals plus minus square root of 2/3, right? Because this will be 0. So all I'll have is plus minus square root of 2/3. So now that's quite obvious to see that for the single x, I'm actually getting two different values of y. So your intuition should say that is not a function, right? Because for the single value of x, we're getting a positive square root of 2/3 and a negative square root of 2/3. So for a single value from the domain, we can get two different values of the range. So that's not a function, okay? Okay, so I'll see you in the next recording.